Good morning, one and all. Session 1, it's going to be on the topic Introduction to Econometrics. Let me take the privilege of introducing the resource person, Dr.R.K.Sudhamathi. I'm happy to introduce my colleague in a professional forum of this faculty development program. Let me take this privilege. Dr. R.K.Sudhamathi is an associate professor in management at GRG School of Management Studies, GRGSMS College for Women, Coimbatore. She has 20 years of experience in teaching management program. She holds master degree in business administration and in finance and control. She obtained her PhD in management during the year 2014. She acted as a resource person for many management FDPs, workshop MDPs in finance area. She has also organized FDP sponsored by AICTE. She has about 25 publications to her credit in national and international referred journals. She is guiding PhD and MPhil scholars. She is teaching accounting for management, cost management, and finance specialization courses for MBA students at GRGSMS. Okay, thank you, ma'am. Thank you for giving an introduction on this FTP as a topic of introduction to econometrics. Thank you. Now the floor is yours. Please, ma'am.
Thank you, sir. Thank you for introducing me. So now I will take this session.
Sudha ma'am,
Yes.
Sorry to interrupt.
Yeah.
One participant has asked to enhance the screen. Sir, we will not be able to enhance as like the presenter will have the full view of the screen, sir. But when it comes to the participants will appear on the top and the screen will be visible at the bottom. So if you just keep the cursor at the line below the participants, a border is shown. If you keep the cursor, it will show you an arrow mark. You can reduce that space so that the screen will be wide for you. The PPT will be comfortably visible for you.
Okay.
For the presenter, the entire
Any other instructions? Any other instructions regarding the login, all those things?
No, ma'am. No, ma'am. Most of them have logged in with their appropriate names.
Okay.
Taranya ma'am, one more thing, like they can also use the detach camera button to see only the presentation.
Okay, ma'am.
It is there in the side of the side thing where they can zoom the screen.
Yes, ma'am. So
Detach camera so that they can make the screen bigger, only the presentation. Yes, sir.
Okay, ma'am. Okay, ma'am. Thank you, ma'am. Participants, hope you would have noted it down. Please detach the camera button so that you will be able to see the full. Thank you all for the cooperation. Ma'am, the floor is yours.
Yeah.
Hello, ma'am.
Thank you.
Hello, ma'am.
Yeah. Yes.
Ma'am, just one request, ma'am. Can you please tell others, and you can also switch off your video so that the network is stable here. So, ma'am, we can get a proper flow.
Yes,
Sure, sir. Sure. So,
Please also
good morning,
request other
participants.
Ma'am,
And
please
I
also
welcome you
request
all.
other participants.
gentle request to all participants, please keep your cameras turned off because the consumption of data will be very high. So it will enable better connectivity also for everybody. Please switch off your camera. Our organizers will also keep the camera switched off. Thank you, sir.
Yeah, yes, participants, just to save the bandwidth, even I am switching off my camera. So it's a request that all of you please switch off your camera. So I think you can see my screen. Is my screen visible?
Yes, ma'am, your screen is visible, ma'am.
Yes. So this session it is about the introducing econometrics, because like many of us will be very new to this topic. So keeping them in the mind, I would like to introduce about what is economics, because only then the later part will be clear. So what is econometrics? So econometrics, it means measurement. It means measurement of economics. That is metrics. Metrics itself means measurement of anything. So here econometrics means measurement of economics. So from where this econometrics emerged is that this econometrics rooted from economics. Okay. And you know, like economics, it is a basic discipline which is, which has, from which many other subjects have evolved. Say, for example, commerce, management, everything was evolved from economics. So econometrics, basically, it rooted from economics. So now coming to what is financial econometrics, because nowadays we have started doing research with econometrics. So now we have to understand what is financial econometrics. Financial econometrics, it is nothing but it is application of statistical techniques to problems in finance. Application of statistical techniques to problems in finance is what called as financial econometrics. Because in finance, there are many problems which has to be tackled. Say, for example, the government has to tackle the inflation problem. So they should know like what are all the factors which is influencing the inflation, and they should take decision accordingly. And also the investors, they have to tackle the problems associated with the investment, because sometimes the risk is going up, the return is coming down. So in that case, if they know what factor they have to control and what they should look into, it will help them to take the decision. So with all these views, with all these things, financial econometrics have taken its root. So before going to financial econometrics, let us understand basically what econometrics means. Econometrics is defined as combination of mathematics and statistics. That is, you are using the mathematical models and statistical inferences to analyze about the economic theory. That is what called as econometrics. For example, let us take one of the very basic economic theory which is known to all of us. That is, we all know about the Keynes consumption theory. That is, Keynes states that on an average, consumers increase their consumption as the income increases. So this is the this theory, it is put forth by Keynes on the consumption pattern in economics. So we know about this theory. So testing this whether the consumers will increase their consumption if the income goes up. Testing that is what called as econometrics. So having understood about the econometrics, let us understand about the types of econometrics. Econometrics, it is of two types, that is theoretical econometrics and applied econometrics. So what is theoretical econometrics? Development of appropriate method of measuring economic relationships specified by the econometric model is what called as theoretical econometrics. Say, for example, we looked into the example of consumption and income level, Keynes theory of consumption. So here, like it is stated that if the income increases, the consumption will increase. It is stated. So it is
Ma'am? Sudha ma'am, we couldn't hear you.
Madam?
I
Madam.
think there is some connectivity issues. Sabri sir.
Yes, yes.
I think ma'am has got some connectivity issues.
Least square method. So we adopt a model. Yes.
Sudha ma'am, few minutes back there was a break in the audio. We couldn't hear you when we were talking about the income consumption concept. When you changed the slide, we weren't able to hear you, ma'am.
Okay. So now, okay, I will try if there is any problem, like you just tell me.
Okay, ma'am.
So what is econometrics is that econometrics, it is combination of mathematics and statistical inference that are applied to analyze the economic theory, because n number of economic theories are there. So you are trying to analyze those econometric theories by combining your mathematics and statistical inference. That is what called as econometrics. So now is it clear, Saranya?
Yes, ma'am. Yes, now it's okay.
Okay, sir. Okay. So that is what called as econometrics. So in order to understand about the econometrics, let us take the simple theory which was stated by Keynes. So according to Keynes, the average Keynes states that on average the consumers increase their consumption as their income increases. So this is one of the which is simple theory which is stated by Keynes on consumption and income relationship. So having understood this, let us understand about the types of econometrics. There are two types of econometrics, that is theoretical econometrics and applied econometrics. So what is theoretical econometrics? That is development of appropriate method for measuring the economic relationship specified by the econometric model is what called as theoretical econometrics. Say for example, in the example we saw that the relationship in the theory, in the economic theory stated by the Keynes, the relationship has been established between the income and consumption. So now we have to measure this. We have to measure this theory. So in order to measure this theory, developing the appropriate method is the role of theoretical econometrics. Okay. So this example, what I stated, the relationship between the consumption, whether the relationship between the consumption and income exists according to the theory which is stated by Keynes. To measure this, we normally use the least square method. Least square method is used. So suggesting this method, this least square method will be appropriate to measure this. That is what it is addressed in the theoretical econometrics. And beyond that, the theoretical econometrics also spells the assumptions behind which the theory has to be measured. Behind which the theory has to be measured. And also it spells out the properties. It also spells out the properties to be taken into consideration while measuring the economic theory. And also it also tells about theoretical econometrics also tells about if certain properties are not met with, in that case, like what will happen to the result, that is also addressed in the theoretical econometrics. Okay, so now even we can relate this with the finance examples. Say for example, we all know very well, like we have something called as capital asset pricing model, arbitrage pricing theory, and likewise we have so many theories in finance also. Even those things can be measured by using the econometrics. So that is the reason why we are applying the econometrics in financial research. Even things like we have dividend theory, capital structure theory, even all these things can be measured by using the theoretical econometrics. So econometrics has approach for all these things. And coming to the next type, applied econometrics. So applied econometrics. In applied econometrics, we use the in the applied econometrics, it is all about the tools which we are going to apply in order to prove our theory. That is what called as
Sudha ma'am, once again there is a break in the voice. Sabri sir, can you hear Sudhamathi ma'am?
So in applied econometrics, what we do is that we translate the qualitative economic statement. We translate the qualitative economic statement into quantitative one. Okay, in applied econometrics, we develop a technique, and by using the technique, we translate the qualitative econometric statement into a quantitative one. Okay, say in the example what we have taken, there it is qualitatively, it is stated that if the income level increases, consumption will increase. It is qualitatively stated, but we are proving that quantitatively. That is what called as applied econometrics. So with this small explanation on econometrics, let me move on to the methodology involved in econometrics. So whenever anything has to be tested, because now we understood that econometrics deals with proving something. Okay, so when we take that task, some methodology has to be followed. So what is the methodology we are going to follow? Let us look into that methodology of econometrics. So this is not only for the econometrics, but this also applies for research in finance also. So the first step in econometrics is that statement of theory or hypothesis. Okay, first you have to take a theory, or you have to state a hypothesis. As mentioned in our example, we are going to test the consumption. We are going to test the consumption pattern. That is, we are going to test this Keynes theory. If income increases, the consumption will increase. We are going to test this. So first we have to state the theory or hypothesis which we would like to test. And then the second step is that specification of the mathematical model of the theory. That is, as a second step, we have to check we have to check where we can fit in this theory, and we can test it. Okay, say for example, we can fit in this theory with the regression equation. Okay, so this regression equation, it is a mathematical model which is already given by mathematicians. So we are going to use this mathematical model in order to test the relationship between the consumption and income. Okay, so now we are going to state it in the form of equation. Okay, so this is the equation. So here, so that is the second step. So here, the y it stands for consumption. Okay, because it is a dependent variable, and income income is represented by x because it is an independent variable. Because we are trying to prove that when income increases, it will also increase the consumption. We are trying to prove that. So now we have expressed that by using the mathematical model. And then, so this is the second step. And then the third step is that specification of the economic model. Okay, this is a mathematical model, but now you have to put forth in the form of economic model. Okay, there is a little difference between the mathematical model and econometric model. Okay, because like econometric models, it is something which is real, which is of a real scenario, where there will be some deviation. Okay, see, your income, because of the increase in income, your consumption is increasing. Okay, that is okay. But beyond that, there will also be other reasons. There will also be other reasons why your consumption is getting increased. Okay, why your consumption is getting increased. So that other reasons is captured by this term called as mu. Okay, which represents error. Okay, which represents error. Okay, so take the theory, relate it with the mathematical model, and then according to that you put forth it in the econometric model. Okay, then as a fourth step, you have to collect the data, because now we are going to prove the theory. So in order to prove the theory that the consumption increases as the income level goes up, you collect the data. Okay, so here in this example, I have taken the personal consumption expenditure which is available for the country has been taken. And similarly, in order to represent the income, the gross domestic product of the country has been taken. So you collect the data related to the theory which you want to test. So once you do this, the next step is to estimate the parameters of the econometric model. Okay, to test the parameters of the econometric model. Because here we have already represented that in the equation form. So now you calculate the intercept and you calculate the coefficient. Calculate the intercept and coefficient. So how do you do that? So by taking the method to do that, there is method which has been recommended. So according to that, you have to do it. Say for example, here in order to analyze this regression equation, the method which is recommended is least square. So according to the least square, you estimate the parameters. So once you estimate the parameters, as a next step, you test your hypothesis. Okay, you test your hypothesis. That is what you wish to test. Here you wish to prove that income and consumption is related. So if you want to prove that, frame the hypothesis that it is not related and it is related. That is, you can have the null hypothesis as not related and alternate hypothesis as related, and you can test that statement. So that is what the hypothesis testing. And then once you test the hypothesis, and if it is proved that there is a relationship between the consumption and income, as a next step, you can use this econometric model. You can use this model in order to forecast or to predict. You can use this model to forecast or to predict. Okay, once you estimate that A and B, that is intercept and coefficient, once you estimate that, next you use this for forecasting or for predicting. So when you forecast or predict, okay, normally say here in this example, we have forecasted for the year 1997. So for the year 1997, according to the data, according to our equation, solving the equation, we arrive at this answer. Okay, we arrive at this answer, that is 4951.3. So this is our forecasted value as per solving the equation. Let us go back to the real data and let us see what is the answer? Okay, 1997 data is not available. Okay, so so we forecast. We can forecast the we can forecast. Okay, but always the forecasted value may not match with the real value. Okay, always the forecasted value may not match with the real value. So here the actual value is given. That is the actual value in the year 1997. The actual value of consumption is 4,913.5. Okay, but our forecasted value is 4,951.3. Okay, so according to our model, we have over predicted. That is, there is error of 37.82. There is the error of 37.82. So why it happens like this is that it happens like this because of the error term, that is U. Okay, in the formula I showed you U, that is this U. So because of this U, the it is over predicted, because it gives us the information that it is not only the income, but there are also it is not only the income, but also there are some other factors which influence the consumption pattern. Okay, it is because of that only there is no matching between the predicted value and actual value. Okay, so this error term is the most important term to be pondered in research. Okay, so that we understand exactly what the problem is and we try to control it. So that's about the forecasting and prediction. And finally, we use the model. Okay, finally we will use the model for the intended purpose. So these are all the steps involved in hypothesis testing. Okay, so this basic understanding is required in order to deal with all the research problem. So this is the graphical representation of the regression equation. So we take the variables. So in the example we discussed that we have two variables, that is y and x. So y it represents consumption and it is the dependent variable, and income is independent variable. So when you plot that on the graph, this will explain about the regression equation. So you are taking your independent variable on x-axis and you are taking your dependent variable on y-axis. As y changes, as you give the x value, you can find out the y value. Okay, so here this term, this beta 1, this is what called as intercept, and this is the coefficient. Okay, this coefficient beta 2 will explain the rate of change. In the regression equation. Okay, so this is about the regression. So haven't understood some of the basic things behind what is econometrics, its types, and steps involved in hypothesis testing. Now let us move on to what is financial econometrics. So financial econometrics, it is nothing but, again, you are taking the financial problems. Okay, you are taking the financial theories for testing by using the econometric tools. So that is what called as financial econometrics. So where do we find the applications of financial econometrics is that the financial econometrics can be applied in all these areas. Okay, the first thing is that it is useful in testing the theories in finance. We know very well that in finance, we have n number of theories. Okay, like we have market efficiency theory, and we also have something called as capital asset pricing model, arbitrage pricing theory. Likewise, we have n number of theories. So you can take these theories and you can test it by using the by applying the econometric models. And the second application is that it also helps in determining the asset prices or returns. Okay, it helps in determining the asset prices or return. Okay, say for example, you have invested in 10 companies, or you have invested in stocks of 10 companies. So you want to determine your return, and if you find out the factors which influence your return, maybe something like the market, your stock market movement in general, and about the industry movement. So if you could able to pick the factors, you can relate those factors, and by using the econometric model, you will be able to determine your future return. Over there also, the financial econometrics is applicable. And also the econometrics is also applicable for testing the hypothesis concerning the relationship between the variables. Say like you are interested in analyzing some variable. Okay, so you can take those variables and you can test it. Say for example, you would like to test what are all the forces that determines the stock market movement. For example, the stock market movement may be influenced by exchange rate, or it may be influenced by foreign institutional investment, and there are n number of macroeconomic factors which we can go on listing. So now you are testing whether the stock market movement is influenced by all these variables. You can test it. So over there also, your financial econometrics is applicable. And financial econometrics is also applicable in examining the effect on financial market to changes in the economic condition. Okay. So as I said already, you can take some macroeconomic variables and you can relate the macroeconomic variables with the financial market movement, and you can test, you can examine which major macroeconomic factor is influencing the movement of the financial market. So that also you can test. And then also it is helpful in forecasting the future values of the financial variable. Okay, if you want to forecast any of the future value of the financial variable, over there also your financial econometrics comes into role. Okay, say for example, you would like to know what is going to be the stock market movement after 2 days. Okay, so that you can take the decision with regard to whether to buy a share or whether to sell a share. So for that also you can pick out the factors, you can filter the factors, you can put them into a model, and you can test it, and once that is okay, then it can be used for forecasting. And finally, the financial econometrics can also be applied in financial decision making. Okay, in order to decide about your investment, or if it is a company, they can make n number of decisions by using the by applying the financial economics. So this is what the application of the financial economics. So hope you understood so far. Hope all of you understood what is econometrics and what is financial econometrics.
Yes, ma'am. Yes.
Yeah. So now we will proceed to the difference between the financial econometrics and economic econometrics. Okay, so basically the tools which is used for economic econometrics, that is used over here also in financial econometrics also we use it. Okay, but before we decide to use a particular tool in order to analyze about the finance problems, we should know that financial data little bit it differs from the economic data. Okay, the difference we have to understand so that we pick up the appropriate tool, or we do the test which is associated with the tool in order to use the most effective model to prove or disprove our financial problem. Okay, so financial data differs from macroeconomic data in the following terms. That is, the first thing is that it differs in terms of frequency. Financial data differs in terms of frequency. Say, for example, if you take share price, it is a financial data. We consider it as a financial data. So the frequency of share price will be high. As and when you trade, the share prices will move. So the frequency is high. But when you take economic data, say for example, GDP or population or income level, if you take such kind of economic data, the frequency is less. That is, if you take GDP, the frequency of availability of GDP is minimum quarterly data we get. So that is the frequency. But whereas for share price, it is not like that. As and when you trade, every minute you trade, you have frequency. But of course, finally we take closing price when we do the research. So in that way also, if you look, the frequency is high for the financial data. And then the second point where the difference comes is that accuracy. Okay, accuracy. As far as the financial data is concerned, what it happens, we take as it is. Okay, say for example, when you take financial data with respect to dividend declaration by the company. So once the dividend is declared, you take the data as it is. So accuracy is there. Okay, accuracy is there. But whereas in case of economics data, the accuracy will differ. We can't say it is not accurate, but the accuracy will differ. Okay. So here the example what I would like to mention is that, say for example, you take the public expenditure and income level. So public expenditure by various government they will have measured. Okay, they will have the economic data. But how do they measure that public expenditure? Okay, the measurement method may vary from one period to another period. Okay, say for example, they are measuring the income level of people in the country. So the method what they use to measure the income level may differ. So because of that, your accuracy may vary slightly. Okay, so in terms of accuracy also, the financial data and economic data, it differs. And then third one is that with respect to the seasonality. Okay, so what do we mean by seasonality is that by seasonality we mean periodic fluctuation. We mean periodic fluctuation. So this periodic fluctuation, it is quite natural, and it can be very easily captured in economic data. Okay, in economic data, very easily you can capture it. Say for example, like the expenditure, expenditure level or expenses level of the household. So expenses level of household, it will have its own seasonality. So very easily you can measure it. You know, like during the festival time, normally people they will spend more. Okay, so very easily you can capture it. But whereas in case of financial data, it is very difficult to capture the seasonality. It is very difficult to capture the seasonality. So you should have a very accurate or very sharp measure in order to measure the seasonality. And the financial data also has some other properties, like they are more noisy and they are not normally distributed. So what is more noisy is that, again, we can relate this to seasonality. Noisy is that it is more difficult to separate the underlying trends and patterns, okay, from random and other uninteresting features. Okay, all of a sudden, all of a sudden some information flashes, so immediately the stock market will act for that also. Okay, but then that may not be that may be an uninteresting factor for the long-term investor. So the financial data are always, it is highly noisy. Okay, which so that makes it difficult to separate the underlying trends. So accordingly, you have to choose the model when you forecast the financial problem with a model. And also another property to be understood is that the financial data are not normally distributed. Okay, the financial data are not normally distributed. So this is the difference between the financial econometrics and economic econometrics. So having understood this, now let us move on to the different types of data. So before we proceed with the research, always we should have some basic understanding about the type of data what we are going to deal with, so that it will be helpful for us in choosing the appropriate model, appropriate econometric model for our analysis. Okay, so let us understand about the types of data. So coming to the first type, time series. First type, time series data. So time series data are data that have been collected over a period of time on one or more variable. Okay, on one or more variable, if you are collecting, if you are collecting the data over a period of time, then that is what called as time series data. Okay. One of the peculiar feature of the time series data is that it has a particular frequency of observation. Okay, it has a particular frequency of observation, and that will not get changed. Say for example, daily. Okay, if you take stock prices, you can decide to collect a daily closing price. So the frequency which is fixed over here is daily. So it has a particular frequency. Okay, which can also be referred as collection of data point. You can decide, because you know, if you take share trading, as and when the transaction occurs, you have share price movement, but you decide on one thing. Okay, I will take only the closing price. So you decide on one thing. So likewise, you take a particular frequency. Okay, so time series data are the data that have been collected over a period of time on one or more variable. Okay, for example, if you take industrial production, data, monthly data, quarterly data, these are all the frequencies. Okay, and it will be available over a period of time. It will be available. So it is a time series data. Similarly, government budget deficit. If you want to observe something on government deficit budget, so this will be available only annually. Okay, only annually it will be available. So the frequency over here, or a data collection point over here, is annual. And then GDP, quarterly data are available. So that is the frequency of this GDP. And similarly, stock price, as transaction occurs, you will as the transaction occurs, the stock price data can be collected. So these are all so this is what called as time series data. So so I told that time series data is not only for over a period of time, but also sometimes it can be on more than one variable. It can be on more than one variable. Okay, say for here is the example which here is the example which tells about it. That is, here you can see for a particular city, New York City, on different dates you can see the different variables. It's not only one variable, temperature is measured, but also the other variables like humidity, wind, everything is taken into consideration. So on more than one variable also you can collect the data over a period of time. That is also called as time series data. So the next is cross-sectional data. A cross-sectional data are data on one or more variable collected at a single point of time. Okay, on a single, a data on one or more variable which is collected at a single point of time is what called as cross-sectional data. Okay, in cross-sectional data, normally there is no natural ordering of the observation. Okay, say for example, with regard to the companies in IT industry, you are collecting the data with regard to their profit for the year 2019. So there is no particular order like you have to place the company 1 first and then company 2, nothing like that. Okay, you can take all the IT and ITES companies in IT industry and you can collect the data pertaining to their profit. So that is what called as cross-sectional data. Okay, so here are certain examples which will help us to clarify about what is cross-sectional data. That is the closing price of the group of 50 stocks at a given moment. Okay, that is on the example. For example, assume that New Year Day on January 1st, what is the closing price of the stock of different companies in Nifty 50 companies? If you want to see, then that is what called as cross-sectional data. Okay, another example which explains about the cross-sectional data is that it is a financial position of different companies at a point of time. Okay, as I said, if you want to analyze the financial position of pharmaceutical companies, because they are in peak now. So if you want to analyze the financial position of the pharmaceutical companies, taking the data related to the company at a particular point of time, say for example on 31st December 2020, then that is what called as cross-sectional data. And there are also the other examples also you can relate it to the cross-sectional data, like inventory of a product at a specific store at a particular point of time, and also the grades obtained by students, by class of students on a given exam. These things will narrate what is cross-sectional data. So here is an example which will give better understanding about the cross-sectional data. So here you can see for different cities. In the previous example, we saw only for one city. For one city on a particular date, on different variable, what is the maximum temperature, humidity, and wind, all those things. Similarly here on a particular date. Okay, it is only one point of time. On a particular date for different cities, okay, on different variable, you are collecting the data. Okay, so that is cross-sectional data. And then next, coming to the panel data. So panel data, it can also be called as longitudinal data. So panel data, it will have the dimensions of both the time series and cross section. Okay, so panel data contains the observation of multiple phenomena obtained over multiple time periods for the same firm or individual. Okay, say for example, I told about the financial performance of the pharmaceutical company. So financial performance of the pharmaceutical company on various important financial performance parameters, if you take like profit before tax, and then sales figure, and then their dividend payout ratio, so many other dimensions you can include. for different companies, okay, for different pharmaceutical companies for different period, okay, for different period. If it is so, then that is called as panel data. Okay, so let us have an understanding what is panel data by looking into this example. So here they have taken 3 cities. Okay, they have taken the 3 cities for 3 years, for on 3 different dates. That is during the beginning of the year 2013, 14, and 15. What is the maximum temperature, humidity, and wind they have taken? So similarly, if you take the case of financial research, in financial research also we have panel data. Say for example, for a pharmaceutical company, if you are collecting the data on financial performance of a different pharmaceutical company for 3 years period of time, or for 5 years period of time, or 10 or 20 years period of time, then that becomes the panel data. So having understood about the time series, cross-sectional, and panel data, okay, now let us differentiate between these things. So understand that time series data, the important factor where that comes into role is that the collection of observation. Okay, collection of observation is one thing. It may be on collection of observation, and then the second thing is that single subject matter. About the single subject matter only you are collecting the data, but the time period is a different period of time, and that time period it is generally equally spaced. It is generally equally spaced. So that is what called as time series data. But whereas if you take the cross-sectional data, okay, it is collection of observation for multiple subject matter. Okay, for multiple subject matter. Time series is for single subject matter, but whereas cross-sectional data, it is for multiple subject matter. Okay, for multiple subject matter at a single point of time. At a single point of time. That is what called as cross-sectional data. And panel data. What is panel data? It has both the characteristics, both the features of cross and time. Okay. Say for example, it is for collection of observation of multiple subject factors on at multiple instance. At multiple instance. Okay. So for a different time period and as well as on different subject matters. So that is the panel data. So these are the basic difference between time series, cross-sectional, and panel data. And there is also one more data type, that is pooled data. Pooled data. So again, pooled data sets, again, like it has the characteristics of both the cross-sectional data and time series data. Okay, it has the characteristics or it has the features of both the cross-sectional and time series data. Why it is called as, so in this way, if you see, it will be similar to our panel data. Okay, this data, pooled data will be similar to our panel data. Okay, but where the difference comes is that the difference comes in pooling, that is in combining. Okay, the difference comes in pooling, that is in combining the data. Okay, say for example, I told about the analyzing the financial performance of the company for different company for different time periods in a particular industry. If you have a data, say like you would like to analyze about the financial performance of various companies before merger and after merger. Okay, before merger and after merger. So before merger, you take the various parameters on the financial performance of different companies, and also after merger, you take the various financial performance parameters of various companies for different period. Say before merger 5 years, after merger 5 years. Okay, if you take that and if you merge it, then that becomes the pooled data. Then that becomes the pooled data. Okay, so where this pooled data will come into role is that if you wish to study the impact of a particular event or a particular happening, in that case the pooled data will be helpful in doing research. Okay, say the effect before merger, after merger. If you want to study that, you have to go for the pooled data. Okay, say like if you want to analyze, another example is that if you want to analyze the effect of the new government policy, any of the new government policy, in that case also you can go for pooled data analysis. For anything you want to analyze before effect and after effect, then you can go for pooled data analysis. Okay, for example, if you want to analyze on a government policy, to what extent the tax revenue collection has been tax revenue collection has been enhanced because of the GST. If you want to check that, maybe you can analyze on the data like what is the revenue mobilized by different states of India before and after the implementation of GST. Can be looked into to analyze about the impact of GST. So that's about the pooled data. So I think like I have given a good understanding about the various types of data. Is it clear about the various types of data?
Yes, ma'am.
Yes.
Okay. So these are all some of the basic understanding what we should have when we start with the research. What is econometrics? What is how we bring that econometrics into finance, and what are the different types of data, and so all these things are some of the basic things that we should know before we proceed with the research. So with all these basics, now let me finally touch upon one simple topic, that is what is hypothesis. Okay, hypothesis testing is all about. So in finance, normally we take a problem and we test that problem. Normally we take a problem or we take a theory and we test that theory. Okay, or we want to test a particular statement. Say for example, the stock market, the return on share price, the particular share price is influenced by the market movement, by the share market movement. So we want to prove this simple statement. So for that, we have to do the hypothesis testing. So what is the procedure? What is the procedure involved in doing this hypothesis testing? Okay. So if you want to test any hypothesis, first of all, you should formulate. You should first step in hypothesis testing is that formulate hypothesis. Formulate hypothesis. Okay, the hypothesis, it need not be in the equation form. It can be any other statement. It can be any other theory also. So here, for the sake of simplicity, I have taken this hypothesis. Okay. So here we can have the example of like testing the same the conception example what we discussed earlier. That is, your conception Y is influenced by the income. Okay. So you formulate the hypothesis. Once you formulate the hypothesis, the second step is that you set up the suitable significance level. Okay. Significance level for testing you set up. So normally the significance level which is set up for testing the hypothesis will be either 5% or 1% level of significance. At this significance level, we will test. Okay. So lesser the significance level, the more will be the accuracy. And then the third thing is that select the test criterion. Select the test criterion or the model. Okay, if we take primary data analysis, normally we select a particular test criterion. Say for example, chi-square test, F test, T test. Likewise, we select the particular test criterion. Here, mostly in case of the financial, when we apply financial econometric, we select a particular model. Okay, and under a particular model, we will be executing the model, and we will be looking in for the various parameters. Okay, say for example, if we take the simple regression analysis, if we decide to apply simple regression analysis for our research problem, then we will be looking into the coefficient value. We will be looking into the coefficient value mainly. So you tell it, you select the test criterion what you would like to apply, and then you compute the test statistic. Okay, so if you take this simple test statistic, it can be anything. It can be either t value or f value or p value. You compute the test statistic. Say for example, if you take this regression analysis, for regression analysis, in order to decide whether the model is okay, you can look into coefficient number 1, and also you can look into the p value to decide on, and also the f value, t value, all these parameters you can look into. All these things you can look into. So for that you compute the test statistic, okay, by using software. And then finally you make a decision. You make decision with regard to accept or reject. Okay. So with regard to accepting or rejecting null, how do we do it? So we do in this way. That is, say for example, I told like we have to decide our significance level. Okay, so let us take the significance level is 1%. Okay, if your p value falls between 0 and 0.01, if your p value, if it is within this range, then you reject null. Okay, if you have kept the significance level as 5%, okay, in that case you look for your p value, and if your p value is between 0.01 to 0.05, in that case also you reject null. And if it is greater than 0.05, you accept null. That is, here your hypothesis, I mean here, like because of this, since the p value is greater than 0.05, it becomes insignificant, and you accept the null. Okay, so this is how you have to accept or reject the null. And then how to interpret this significance? So if you say significant at 1% level, what it means is that the 99% probability of accepting or rejecting null hypothesis is correct. Okay, and if you tell that your significance level is 5%, then 95% probability that accepting or rejecting null is true. So this is how you accept or you reject null. So with this, I would like to conclude about the topic. So thank you for patient listening.
Thank you,
If
ma'am.
you have any questions, I will take up the questions.